Hello everybody, my name is Nami Rabbit here on Sushi Tsunami with another splendid first video just for you, and today we are doing a presentation on acid rain. Yeah, I know, it's a little weird, it's not like what we usually do here on the channel, but I have an assignment, so here we go. What exactly is acid rain? Well, we know what precipitation is. It's the normal rain, snow, sleet, hail, etc. So acid rain is actually precipitation that has a higher acidic rate than normal rain. Typically, it contains high levels of nitric and sulfuric acids, which can be caused by rotting veggies, volcanoes, and industrial pollution, so human activity. When we burn fossil fuels, sulfur dioxide and nitrogen oxides release into the atmosphere. When it rains these acids, it runs off into our water or sinks into our soil. This is called runoff, and we will discuss it more later. Okay, to define acid rain from normal rain, let's take a look at this little thing here called the pH scale. Yeah, it's pretty, isn't it? It's really colorful. So basically what the pH scale measures is it measures the acidity levels that are in a said solution. 7 is the neutral level, and typically you can find normal water at the neutral level of 7. I say typically because normal precipitation actually has a acidic level of its own due to other impacts in the environment. We'll talk about that more later as well. So the lower number that you go on the pH scale, the more acidic the substance is, whereas the higher you go on the pH scale, the less acidic a substance is, or as you could also say, the more basic. The difference between normal rain and acid rain. Well, normal precipitation, including rain, hail, snow, etc., has a natural acidic level as a result of its interaction with the many gases that linger in its surrounding atmosphere. So we have all these gases floating around us, and it's in our air, and it interacts with that precipitation, making it more acidic. Normal precipitation, unlike water, is more acidic and tends to be found at around 5 on the pH scale. Just because it's acidic, however, does not mean that it is acid rain. This is just normal precipitation, normal rainwater. What differentiates acid rain from normal rain is that acid rain is typically more influenced by sulfuric pollution in the atmosphere and makes it even more acidic than that normal level. The reason we should care. Well, basically this whole PowerPoint is why we should care, but acid rain is a hazard to our environment, and we rely on that environment and this planet to live. Plus, we kind of contribute a lot to acid rain. Acid rain enters our soil and our water, so the place where our food grows, and you know, that thing you drink to survive. It's important. It's killing vegetation, changing environmental living conditions, and making it difficult for other wildlife to survive as well. It throws our whole ecosystem out of balance. On top of that, the amount of acid rain that we're finding in any given area seems to be increasing as the years go by. It's a growing problem and we should be concerned. Some of the facts. Well, certain studies do actually argue that acid rain is not really having a huge impact on our environment. The reason why this argument stands is because certain rocks and minerals that exist in our ecosystem actually do neutralize the effects of acid rain. They have these things known as alkali water pods or water pockets that it's basically a substance within certain rocks or minerals or a quality of them that when it interacts with the acidity levels in acid rain actually takes away some of that acidic level and basically turns it into normal rain. The only issue with this argument, I would say, is that, well, yes, it is true that our environment does use this method as a natural way of cycling through the acidic levels of naturally produced acid rain. A good deal of acid rain is actually caused by human activity, and as a result, our environment doesn't know how to handle it. The environment is equipped to handle the amount of acid rain that it itself naturally produces. When we cause more than the normal amount of acid rain in our environment through man activity and human industrial pollution, it throws more acid rain at the environment than the environment initially knows how to deal with. And this can be a problem. As a result, our environment can't keep up with the amount of acid rain that we are causing our environment to hurt itself with, and it throws the entire cycle out of whack. Some of the effects of acid rain are that it raises pH levels in the soil, lowering soil quality, and hindering crop growth. Soil degradation is caused through acid rain as well as certain other factors, but acid rain is the one we'll be looking at here, obviously. As the acidic levels go up, the soil quality and types of soil we have change because it's changing the surrounding environment that allows those types of soils to thrive. As this happens, it becomes more difficult for human farmers to have good quality crop growth because, well, the soil doesn't support it. It also contaminates our water, killing fish or preventing their eggs from hatching. It also contributes to pollution in the water, which, while it does not directly, as acid rain alone, cause anything in particular, it can cause mutations if combined with other pollutions in our water. And for the fish and wildlife that don't die, it prevents their eggs from hatching, which is not good for our ecosystem because certain other animals that we might rely on for certain things rely on those fish. Everything is a constant cycle. One of the other things we should care about is oftentimes in society we have certain monumental pieces of artwork or buildings and architecture in our society that we heavily rely on or that we greatly look upon as a historical piece in our timeline. Acid rain has very bad corrosive properties, and when it hits buildings, sculptures, whatever we have that's outside, it actually eats away and greatly damages those structures. Something to think about. Where are you from? Where are you living? Well, acid rain has effects all throughout the U.S., as you can see here, but really it's one of those things that has effect pretty much globally because there is some level of sulfuric pollution in most areas. The only difference is that the areas with high industrial activity or volcanic activity will tend to have more acidic properties to their acid rain or more severe cases of acid rain. So that's something to think about. How much industrial pollution is there in your area? How much sulfuric acid is coming from nature and from human activity in the place that you're at, in the place you are from, in the places you know? Because that, in turn, helps to kind of determine how strongly acid rain is affecting that place. Yeah, that big yellow chunk. It's kind of terrifying. So, fossil fuels. They're good, they're bad, they have pros and cons. One of the things to think about with fossil fuels is, well, yeah, fossil fuels, they give more energy than most of the other fuel sources that you see on here. Great. But they also are very, very hazardous to our environment, and acid rain is no exception. Fossil fuels do contribute to the problem of acid rain, and that's something else to consider when you think about all of the different types of fuels and energy sources that you use throughout your daily life. Runoff. See, guys, I told you we'd be back to this. Runoff is the thing that I mentioned at the very beginning. When it rains, it has a lot to do with the natural water cycle. So, if you don't know, the natural water cycle involves the action of precipitation falling down to the earth. It then either sinks into the soil or it runs off a high elevated surface to a lower one, which usually is a body of water in our society somewhere, or in our environment. So, something interesting to consider is acid rain follows the same exact pattern as normal precipitation. It rains, it goes into the soil, as I talked about, that causes soil degradation and it lowers the soil quality, or it runs off into our water, and this better explains and helps you understand how exactly it's polluting our soil and our water system. Another thing to consider is that while yes, in its interaction with the soil and the water, it may come across certain minerals and rock structures that help to neutralize its acidic effects, but oftentimes this probably doesn't happen or it doesn't neutralize it all the way. Then that water evaporates back into our system and it rains again, and our environment has to deal with those same corrosive properties of that acidic rain repeatedly, multiple times, because it is a cycle that repeats itself. This can further the damage that the acid rain is doing, but if there was less of it to begin with, or less acidic levels in it, it wouldn't be as much of a problem because our environment could actually truly neutralize all of the problem that is there. Whereas right now, it can only do it to a certain degree or only do some of it. These are important things we need to think about because our ecosystem, our environment, is really the only one we have, and something to think about is, yes, nature, it's pretty adaptable. A lot of the animals, a lot of the things, they're probably going to find a way to develop ways of coping with it, but people won't. We're not destroying nature, we're really just destroying the environment in which nature has provided for us to survive, and we're destroying ourselves. That is a reason to care. That is a reason to be concerned. If you didn't know what acid rain is, now you do. I hope that you guys all enjoyed this presentation. Some of the sources that I found to give you this information can be found here. I will also post them in the description below. I hope that you guys all enjoyed this information that I have provided you here on acid rain, and I hope that if you haven't already, you'll scroll down and click that little red subscribe button, hit that like button, and leave your comments in the comment section below, and I hope to see you all in the next Splendiferous video. Bye-bye, everybody!